Welcome back to KK Automation. I'm glad you're here. Today we're going to take a big step forward and implement a PID controller on a Siemens S71200 PLC. Now don't let the name scare you. A PID controller sounds complex, but in TIA Portal, it's surprisingly straightforward to set up. By the end of this video, you'll have a working PID controller running on your PLC. Let's get into it. Before we build anything, let me quickly show you why we're upgrading. What we want instead is a controller that can smoothly adjust the pump speed, turning it up when we're far from the target and gently easing back as we get close. That's exactly what a PID controller does, and it's one of the most widely used control strategies in industrial automation. The first thing we need to do before adding the PID block is create the right environment for it to run in. PID controllers are sensitive to timing. They need to be called at a consistent, fixed interval to work correctly. If we just drop the PID block into our main OB1, it runs at whatever speed the main scan cycle takes, and that's not reliable enough. So instead, we use a cyclic interrupt organization block. This is a special OB that runs independently of your main program on a fixed timer. Here's how to add one. In your project tree, right-click Program Blocks arrow, Add New Block, choose Organization Block Select, Cyclic Interrupt. Set the interval to 1000 microseconds. That's exactly 1 millisecond. Give it a meaningful name, like cyclic OB_PID. Think of this OB as an alarm clock that rings every millisecond. No matter what else is happening in your PLC, this block always runs on time. That's critical for a good PID response. Now let's open the cyclic interrupt OB we just created and add our PID block. In TIA Portal, go to the instructions panel on the right side. Expand technology to PID control. You'll see a few options here. For S7-1200 and S7-1500, we want PID_compact. It's the modern, most commonly used option. Drag the PID_compact block into your cyclic interrupt OB. TIA Portal will ask you to create an instance data block. Accept the default name or rename it to something descriptive like PID_compact_fill level. Click OK. Once it's placed, you'll notice the block appears under Technology Objects in your project tree. This is special. It's not just a regular function block. It has its own dedicated configuration interface inside TIA Portal. Now, let's connect the block to our process. Setpoint SP. This is the target value you want to reach. In our example, it's the fill level we want in the tank, say 5 liters. Connect your setpoint variable to the setpoint input pin on the block. Or navigate to Technology Objects, arrow PID, compact arrow configuration in your project tree. Walk through each section. Controller type. Set what physical quantity you are controlling. In our case, select volume to liter. This helps TIA portal understand the units involved. Operating mode. Set activate mode after CPU restart to automatic mode. Without this, the PID controller won't start running after a power cycle. You'd have to manually activate it every time. Input/output selection. Input, select input, since we're using the prescaled liter value. Output, you have three choices: output, type range, use case, output 0 to 100%, output _PER0 to 27,648, direct analog output module, output _PWM digital on/off, pulse width modulation. We'll use output 0 to 100%. Since our simulation reads percentage values. Process value limits set the range of your process variable. Lower limit 0, upper limit 10 liters in our case. This tells the controller what 0% and 100% of your process range look like. If you're using input _PER, you'd also set the process value scaling here, mapping 0 counts to 0 liters and 27,648 counts to your maximum value. Since we're not using it today, that section stays disabled. Output limits. Leave at the default 0% minimum, 100% maximum. You can set a minimum pump speed here if your pump needs a minimum power level to run. Go online and open the PID _compact technology object. Once online, check the operating mode. Make sure it shows automatic. If it shows manual, switch it to automatic from the online interface. Now, let's test it. Set the set point to 5 liters and watch the trend. What you should see, the red line, pump output responds smoothly, not just jumping to 100%. The black line, fill level, rises and approaches 5 liters. The pump power gradually reduces as we get close to the target. This is already much better than the on-off controller. No hard switching, a smooth response curve. You may notice it doesn't perfectly hit the set point yet, or it overshoots slightly. That's completely normal. The PID parameters, the PI and D gains, still need to be tuned for your specific process. We'll cover that in the next video. Let's quickly summarize what we did today. Created a cyclic interrupt OB running every 1 millisecond, the right environment for PID, added the PID _compact block inside it, connected the set point and process value inputs, configured the controller type, input/output selection, and process value limits, downloaded and verified it, running in automatic mode. The PID controller is now active and already improving our control behavior, all without writing a single line of code. That's the power of TIA Portal's technology objects. In the next video, we'll dive into the PID parameters, what P, I, and D actually mean, how to use TIA Portal's built-in auto-tuning feature, and how to manually fine-tune for the best response. If you found this helpful, hit the like button and subscribe to KK Automation so you don't miss it. Drop a comment below if you have questions. I read everyone. Thanks for watching. See you in the next one.